Why did that motor spin up? So I think I said at the end of the last video that this video was going to be a travel video. I did take some footage while I was traveling, but I could edit that video or I could get back to working on the motor, and I would rather work on the motor. It's been a little bit since I, in real time, worked on the motors, and I don't remember exactly what I had said I was going to do or what I had talked about, so I apologize if there's a little bit of overlap. Oh, hey Kepler! You want to come up and say hi to YouTube? This guy had a medical emergency while I was traveling. I'll talk about that later in the video, but as you can see, he's happy. He's okay. But you definitely scared the hell out of me and made me significantly poorer while I was away. The huge initial part of the development was thanks to my friend Andrew, who's been helping me since the beginning of this project. He was the one who encouraged me to start the channel, actually. But he's been very busy with his own work, and that's part of the reason why the Helm development slowed down a lot. In the meantime, someone named Karsten, who is a viewer of the channel and created a pull request for the M-Helm that did a significant overhaul of the code base to make it more efficient and whatnot. I tried to merge his code, ran into some problems because I'm an idiot and I'm still learning, and he very kindly offered to jump on the phone with me or on a voice call, and we spent hours refactoring the code. With his help, I got the LCD working. Just a whole lot of things got sorted out. This video will not come out until these motors spin. So if you're watching this, the motors have spun. As I sit here right now, I don't know if that's today or later. Right now, I have it set up so that the pressing the brake and whatnot to tell the controllers to turn on or not. I've only got one output. I'm going to send it to both controllers. I hope that's fine. They're all tied through the same ground, so I think it's okay. Yeah, let's see if we can get this working. I labeled all of the switches so I don't have to keep fumbling as much. So right now I can see that it's in reverse, 56% throttle in reverse, and then I'm using the port throttle. The regen is 49%. I think the regen is a little bit messed up, and I'm using the 10 kilowatt motor. So if I go to motor select, now I'm on the 5 kilowatt motor. Pretty easy. Oh, I also got these new metal dials. They're going to be for regen and brightness on the Helm later on. You can see as I move through the throttle, I don't have any markers yet to say where's this, so I'm kind of all over the place right now. But there goes forward, and you can see, oh, it's 400. This is too hard to use. Now I'm on this one, which is in reverse. Go through forward, go through neutral, through reverse. All of it displayed on this output. I freaking love that so much. I can't tell you how happy it makes me to have that Helm control or have that display work. It's so 80s. I love it. Now, I'm starting to understand how much temperature affects the ADCs. I don't know if it's, I think it might be the temperature affecting the potentiometers. I need to figure out how to calibrate that because, again, I can't have the high going above and below those numbers or else the controller could cut out. I don't know how the controller is going to react, but that kind of refinement is going to come later. So right now I'm on the 10 kilowatt motor, regen to 0%. I'm going to put this to neutral. So now I should be reading 2.5 volts, which I am. So let's go to full reverse, and it should go down to something north of 0.0, yes, reverse, because I've got it in joystick mode. It should stay at 100% above 0.05, and it's 0.09, so that's good. And forward, I should stay under 4.95. I'm at 4.83. Oh, it's not 100% yet. There's 100%. 4.90. Okay, so the range on the throttle for the 10 kilowatt is good. Now let's try regen just to make sure that it's working. Okay, so regen right now is at 0%, and that's 0.058. That's a little close, but it's okay. So going all the way up to 100%, 4.90. Okay, I gotta switch the, oh, one thing I need to check is put this back onto the throttle. I need to verify that when the throttle has a real value and I switch to the other motor this changes to 2.5. So right now I've got it in 80% forward. I'm going to switch the throttle over to port, and it went to 0.9. That's not right. Why is that happening? And this is why I do checks before I plug in the controller. Does the regen work? So the regen should be coming down as well. The regen went to 2.45. I think I'm writing to the wrong I²C. If I switch back, does the throttle jump up? I'm on the starboard. Regen is still 2.5. Bring regen to 100%. And this is 4.95. I'm on the 10 kilowatt motor. Okay, that is broken. This should go to 0, and this should go to 2.5 volt, vaguely. What is going on here? Oh, that's the... I was switching the throttle, not the motors. Go me! I'm so smart! That's what happens when you go away from a project for a little bit, is your brain rots. Okay, I have full reverse. Now I want to choose the different motor. So now when I do this, I should switch to the 5 kilowatt motor and it should drop to 2.5. Bam! It's working. Okay, and the regen is currently at 100%, which is 4.8. That's good. So again, when I switch the motor, it goes to 0. Perfect. So now I should be able to come over to the 5 kilowatt motor and see that it's sitting at 2.5 volt. And it is. Now, when I switch the motor, this should ramp down to 0.9. There we go. Now, I'm noticing when I switch, there's no smoothing there. So I need to improve my smoothing logic. Now, it's not the end of the world, and I'm not going to worry about this for today because I know the controller has its own throttle smoothing. But now let's try regen. Okay, so it's at full regen, switch off, and it goes to 0. Switch it on. Now I actually play with the regen. That was the wrong one. There we go. And the voltage is dropping. Okay, so the DACs work. Now the next thing I need to figure out, and I need to remember how this is supposed to work because it's been a while, but I need to remember this for when I wire it. I have signal wires that come out to tell the controller when the brake is pressed and stuff like that. I completely forget how they work, but they are here. I need to remember how to test this. So I turned off the camera and something blew up at work. So now it's several hours and one lawn mode later, and also beer o'clock. Well, cider. So I'm going to overlay this on screen here. Oh, don't spill my thing. There we go. Showing the pinouts for the ULN 2003A, the Darlington array. Completely forgot the name of that. And I can see that I have the foot switch out, which is on pin 1B, which is the yellow wire here. The second one, the blue one here, which is pin 2B, selects the high speed and selects low speed. So blue and green is high speed and low speed, and yellow is the foot switch. And I think the foot switch has to open up in order for the motor to run. When the foot switch is pressed, it shuts off the motor, which is our E-stop. So flipping the E-stop should switch the yellow, and switching the motor speed from high, neutral, low should switch the blue and green. Now the question is, these are common collectors. So when this switch closes, it provides a ground. Right, so right now I have ground. So if I switch the E-stop, that should go 0, and it does. So that means the ground was just opened up when I flipped the E-switch. Close it, and it's back. Right, so now I should be able to move over to pin 2. So currently it's set to slow speed. And what did I say? Blue was select high speed range, but it's on slow speed. Do I have this backwards? Do I have this backwards in Logic? I really need to make a board for this. Oh, there they are. Motor select, speed select. So if I go to neutral, that should open up. It does not. Oh, is it the one that switched to ground that tells it? So right now I have it in turbo speed and it's on the high speed pin. So I bet you now if I move this over, it's going to go low when I put it into low speed. Medium speed, it's open and closed. Okay, so that's working. So now the biggest trick is figuring out how to get this from the bench down onto the floor without pulling any wires apart. I need to make this into a circuit board, but that's another skill I have to learn. Thankfully, I've got some wonderful people offering to help on the Patreon. So I'm sure we'll get that done, but that's not gonna help me today. I guess I'll leave the camera running so that if I screw up and start crying, I get it for YouTube. Because YouTube, it loves drama. I don't, but YouTube does. Doesn't this look so stable? All right. So before I start wiring up the helm, which is now on the floor, and I found all the wires, I need to change the ring terminals on these to fit this. I think one of these two will do it. I ordered them before I left on my trip. The second thing I need to do is I need to remember which two wires I had to flip in order to make the Hall effect sensors work with these motors. So yellow, green, blue. So I need to take the yellow and the blue and swap them for this controller. Few steps in a row. First, change the ring terminals, then swap the pins. I'll finish wiring this up, apply power, connect the serial, program this, then wire that up. 6 gauge, 5/16. Yep, that works. After the last video, I had several people, rightly, concerned that the ring terminal joints on these that I had to double crimp are not going to be very good. Chances are I'm going to replace I'll leave it as it is until I install this on the boat, but when I install it on the boat, I'll probably lob the ends off and cut them to be just the length I need, and then re-terminate them. I'd feel bad about wasting the money on those terminals, but I kind of feel like I already wasted it, and I'll have to get the proper dies before I do that as well. And of course, I don't have the blue shrink tubing, so I need to get the black stuff, and I'll just use black on the ends of them. All right, so I was using the 35 mil for the 4 gauge, and I have a feeling that's going to be too big right now. I might end up having to double these up like I did last time. 25 looks pretty close. 35 looks too big. I'm going to start with 25. You know, it's funny how before you start a YouTube channel, you don't realize a lot about your weird idiosyncrasies of how you talk, if that's the right word. I just wanted to sound fancy saying idiosyncrasies. Anyways, one of the things I noticed is how often, I'm not a fan of William Shatner, but that say a few words, pause for dramatic effect, say a few words. If you ever notice in my videos, especially my older ones, where I seem to ... It's because I'm editing out big chunks of me being just silent for no reason. You know, back before I got into all this battery stuff, I used to think 6 gauge was really heavy wire. Now I look at it and I think, oh, it's so cute and small. I think that actually worked really well. You know, I'm gonna pop this all out. I don't know if I need to do a double. No, that's pretty much one crimp is it. Survives the tug test. I can see air in there. No, I'm not happy with this. I'm gonna do all 3 with the 25, and then I will come through, what's my next size down? 16? 16 is the next size down, and I'll give that some more of a crunch. There, I think I just put that on screen. But you can see there's a bit of a gap all around it. So it survives the tug test, but it's not compressing down. That was just a second for you, but I just spent a bit of time on the phone with a viewer who's helping me make the back plates for mounting all the LEDs and stuff for the helm for later on in the project. Thanks, Will. Okay, back to this. So that was the 25. I think I'm stepping down to the 16 mil to crimp it up tighter. It's a little bit of a pinch like this. So what I'm going to do is, like I did last time, I'm going to rotate it, I guess it's 120 degrees, so that the part that was the rise is now cradled in one of the die's corners. I hope that makes sense. Yeah, that's good and tight. Good and tight. I'm happy with that. Okay, that is sorted. So W, V, U. So as long as I didn't screw up this one, U is going to be here. Right, because the yellows are in opposites. I love consistency. That's not going to drive me mad. You know, I can see the resin they used on this shrink tubing has let go from this slick plastic. I'm gonna have to look online and see if anybody's taken that panel open and see if I can replace these wires. The jacket on this is not nearly as slick as the jacket on this. I don't know what they've changed, but they've changed something. Make sure that doesn't touch the fuse. Oh, I don't like how this is crossing over. Surely you're cool enough by now. I'm putting these straight in like this because this isn't gonna look pretty no matter what I do, and at least this way, I don't know. It doesn't make my brain itch as much. There we go. Okay. Can I do that? I think I'll do that. That's slightly less annoying. I love these Velcro ties so much. I need to look up who this was. A couple of people made the same suggestion, but I want to credit the person who did it first. That Raven 6475, I'll put your comment here. She was the first one who recommended taking the cooling block, because I'm only going to be running one motor at a time. If I take this motor and mount it back to back like this, so the heating or the cooling block is sandwiched between the two controllers, that means that both would have cooling off of the same block, which I think is absolutely brilliant. The one problem I'll have to figure out is the screw holes, as you saw, don't fit this, but that's fine because there's no way I could screw the two of them back to back. So with this one screwed to the 10 kilowatt, if I flip them like this and I create like a clamp that I can tighten down and pushes the two together, I mean, it doesn't have to be perfect. It just has to get some of the heat away. I don't know yet how this is going to work, but I'm absolutely going to be trying that. Brilliant, brilliant idea. So the next thing I need to do then is repin this. Okay, so that comes out. Okay, so this yellow has to go to this blue and this blue has to come to this yellow, which are the bottom pins. So when I did this last time, folks were saying, get these pinning tools. There's a lot, and I don't know which one is which or how any of them work. And I'm gonna roll up on a dock or an anchorage, and if somebody has an electrical problem, no they don't. Actually, who am I kidding? I'm not a trained electrician, but I'll have all the tools. I don't even know how to begin to figure out which tool this is supposed to be that I need. I can't really draw it, but there's a plastic clip that when it slides in, it lifts it up like this, and then it drops down and locks it. I need to get under that and lift it up. This was one of these like 101, and I suspect that they've padded them with a lot of duplicates and whatnot just to get the count up because they want idiots like me to think they're getting a good deal and buying the largest number. But I didn't know how to tell what was a good kit from a bad kit, so I got the highest count because, well, somewhere in here hopefully is the one I need. So you know what, I think I'm gonna try that just thin pin. Oh, there you go. Got the first one. What I'm doing is I'm using this to get under that plastic and peel it up without breaking it while putting a little bit of tugging on my finger, pulling back on the wire. Got it. Okay, yeah, those de-pinning tools are definitely worth the cost. I think it was like $8 for all of that too. There you go. Okay. Okay, now did I just put them back in the wrong way? Nope, blue, green, yellow, blue, green, yellow. Okay, so that's done. There you are. While I was away on the trip, well, you've probably seen in past videos, he's a very nervous kitty and never really been able to pick him up. He doesn't sit on my lap or anything. He's a lovely little boy, but he's not a very cuddly one. Well, my daughter called me in a panic because he was meowing a lot and she could pick him up and he didn't resist, which for him is just like immediately something is desperately wrong. So that was late at night and we took him into the vet the next morning and the poor guy had a urinary blockage. and it was so bad that it had backed up into his kidneys. Somehow, and the vet thinks it was stress, probably with Tatters getting sick and then passing away, and right after Tatters passed, I had to travel on business, so he was suddenly in the house entirely by himself during the days. My daughter was around in the evenings, and my neighbor was coming over to check on him, but still, the vet figures he got really stressed out, and somehow it led to a bladder bleed and a clot, and the poor boy couldn't pee. We took him to the vet, and he ended up being in the vet for 3 nights. If anyone's taken a vet to an emergency hospital, you can cringe at how expensive that was. His potassium levels were so high they thought he might have a heart attack that night, but thankfully he didn't. And his kidney values were like 10 times what they were supposed to be. I had his blood work done a couple days ago, and it's still high, but it's much closer to what it was. But he's still with us. Come here, you want to say hi? Oh! That's about as much as I can possibly hold him. Actually, since he got sick and I got home, he's been much more snuggly. I think he realizes that we'll take care of him. But yeah, this adorable little boy ate up a lot of the project budget. Rich ran on top of my dad's expenses and kept our Tatters' expenses. It's been a little bit of a hit this summer, but Dad is still here, Kepler is still here, and money comes and goes. It'll come back, and we'll be okay. Okay, Kepler's got food. Let's get back to it. Pin down has the wide side off to the left. There we go. Okay, so that's done. I can't apply power until I have the contactor set up. I think I have to get the contactor set up now so that I can power this up, so that I can connect to this and program this before I try to connect that. But I mean, you know what? I can wire all of that up and just not power up the PCB. The physical switch will close the contactor to boot this. I can program it and then power up the helm control. Yes, that's how we're going to do this. Now, one of the things I really struggled with the last time I was putting this together was trying to get the wires jammed into those pins. It was really sketchy. I mean, not to say that this isn't sketchy, but I think I might try making some cables, because I've got these silicone wires, which, I mean, they're at least equal gauge to the wires coming off the other side. So I have 2 connectors I need to plug into, one male, one female. And I'll have to take the connectors and make the wires long. Gosh, it's 8 o'clock already. It's taking so much longer. These are the same kits. Now there's big ass diodes in this that came with these motors, and I don't know what the diodes were for. Anyone know why Golden Motor includes 2 really chunky diodes? If you do, please let me know. For now, I'm going to ignore them. Now I'm not using all of the pins either, so I will have some oopses I can recover from. These are really big. This looks like it's for like 12 gauge or 14 gauge. And I've got these 2 3x3s. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 1 spare. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then I got 6 more in the other one. 10, 11, 12, 13, 14, 15. I got 1 extra. Okay, so they weren't that generous. How do those get crimped in then? Well, I mean, at some point I have to make a go at these. If worse comes to worse, I can call Golden Motor and see if I can buy spares, which I'll want to have anyway. So these rectangular ones are the female, which are going to go with this. These are the male that go with this. I'm going to start with the male because I don't need the Hall effect, so I technically have 7 spares here if I really cock it up. Okay, so this is 21 and this is 11. The rest of the part numbers are the same. It's just the very last 2 digits. So I'll put 11 first, 21 second. You can probably find what these parts are on DigiKey or something. This is what this is for, but this is, well, is the middle one small enough? No, 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 this is way too big for that. Would this work? Not really. I'll probably just have to bend them over by hand. I'm sure there's a proper tool for doing this, but there we go. Okay, so the first one I'm doing is 21. No, the first one I'm doing is 11 because it's male pins. The pins are going to come in through like this. So with these two up and this pin off to the side, the top left is 14, so it goes 14, 6, 12, 11, 25, 22, 33, 7, 34. Signal return, main power return. So the first one we're going to do is a black. Now how long do I want to make these wires? So right now I know what I need to get to here, but that's not really what I'm concerned about. It's how long will they need to be in the boat? Oh, these are going to have to be... So I have a little bit of a dilemma right now. I don't want to have to patch these wires after I crimp them. However, the motor controllers are going to be down the companionway, just above where the transmission is right now. The helm is going to be 2 meters back and about 2 meters up. That is a long distance. 4 meters is... See, I wish I was on the boat. I could actually measure it. So I'm standing at the helm. I'm standing about this high. And the helm is going to be about this height, which is 1 meter. But it has to snake up that metal rail and then jump over into the box somehow. You know what? These blocks are way too big to get down through the post. That's not going to work anyway. Oh, wait, I don't have to worry about that because I can leave, the other end is going to be, I can leave it fine, or leave it unterminated, bring it up through the post into the helm, and then terminate it in the helm box. I don't want to put another plug in there because, well, I mean, I guess I'm just making an extension cable at that point where one side is this and the other side is whatever I run between the helm box and inside the engine bay. Yoink! That's about as far back as it is, which puts me at 140 centimeters. And I said 120 centimeters, it's 3 meters, 9 feet. If I did 9 feet, the ends right now are just going to be loose and just plugged into here, so I can bundle them up and run them up that post, no problem. How many feet were on each of these rolls? It doesn't say how long each roll is. It doesn't say here either. It probably says in my Amazon search history, if I believe it. 9 feet. That's a lot of this cable. The alternative is I keep this relatively short and I just accept the fact that I'm going to have to solder it together at some point. This is where I wish I had like big 100-foot spools of wire. Then I just wouldn't even think about this. Ground, key switch, 12 volt. Oh, I need a 12 volt supply. How did I do that last time? I don't remember having 12 volt. I mean, this is the downside of leaving things for a while. I need to stop and think for a bit, and I need to recharge my mics anyway. I am going to, off camera, figure out what each pin is going to be, and then once I see how many cables of which colors I need, I'll decide how long I think I can get away with. Yeah, back in a second. So as you can guess by the wardrobe change, that took a lot longer than I expected. The main reason why is that, if you recall, well, for you, a few minutes ago, I said that I was worried about running the outputs that control the foot switch, high speed and low speed, from the Darlington array out to the two controllers off the same pins. And at the time I was thinking just about the speed, and I thought, well, whichever one's not in use, it doesn't care what the speed is, it doesn't matter. And I realized, yeah, but the foot switch does. If the foot switch is released, allowing these to spin, or vice versa, I'm forgetting right now which way it was, I would be relying on the fact that this one, or whichever one was not in use, was turned off at the contactor. That would be the only thing stopping it from spinning. I don't like that. I wanted the belt and suspenders. So, let me bring it in. So I ended up creating a second speed select switch, and I relabeled the original speed select switch as, where is it? Gotta create a board. I should have done that a lot sooner. So the old speed select switch is now the 10 kilowatt speed select switch, and I've got a new one that's 5 kilowatt speed select switch. And the reason I broke those up is because I wanted to break up also the ULN. Oh, I have to run the wires to it still. Okay, so I still have a bit more wiring to do, but the controller will now send out over 5 more pins. I'm really running low on I/O on this thing. There will be the There'll be 2 input pins for the new switch. Those are already wired up. And then there's the 3 output pins that go to the Darlington array. Those output pins will control the foot switch, high speed and low speed, for whichever motor dedicated. And then in the software, which the software is getting to the point where it's hard for me to track it, so I don't know if I'm doing anyone a service by showing what I'm doing. So I just did it off camera. The code is up on GitHub if you want to look through it. But it's now set so that whichever motor is not selected, the foot switch is always turned off so that the opposite motor doesn't run. I know that might sound like a pretty simple change, but remember, I'm still learning embedded development and C programming and whatnot, so it took me a long time to get my head around it. So with that code redone, this morning before I turned on the camera, I finished going through and figuring out where all the pins go, and I'm pretty sure I've got them all sorted out now. Part of what took me a long time was that the documentation that I had up before was for when it was running the Arduino, so I had to do some translation to get back to the STM32. Now, I haven't actually loaded my code yet, so after I load it, I'm going to have to do some more testing. Actually, no, before I do that, I need to make the wires to go from... These are the lower side are the inputs coming from the controller. The outputs are what's going to go to the motor controllers. So I need to wire the last 3 inputs, the yellow, blue, and green, for the 5 kilowatt controls. Making cables and pushing cables is not very exciting. So for me, I'm going to spend a few minutes doing that. For you, I think the theme of this video is, well, that took longer than I expected. So while I was trying to wire this up, I realized that on screen right here is the screen record. There's a program I used called STM32 Cube MX. This tool allows you to set up a project in the first place. You go through and you define what each pin does and how it works. You run it and it dumps out basically the foundation of your program, and you start adding your logic into it. Now, in theory, you should be able to add in your logic and use this and update it, and it's got like sections, you know, put your code between here and we won't clobber it. But I don't trust that. So, over time, this has fallen out from what's on Cube MX. On PB5, I had tried to set that up as speed low switch, 5 kilowatt out, but it was already in use by Motor 5K Select. So I had to rework some things to get it working. That's done. The code compiles. Does it work? I don't know. I brought you back because I'm going to try to compile it and find out. All right, so it's a good start. I didn't have any smoke come out yet. So now update Helm. It's off, rebooting, throttle stop. Okay. I'm going to have such a fun time trying to turn this into a circuit board. Something I have never done before, which, I mean, I just keep saying that about everything in this project. Oh, right, the Darlington array connects the ground. I have to bring the 12-volt line in off of the controller into pin 9 of the Darlington array, and then when I provide a signal, it closes the connection between the 12-volt and the out. This is why this could be a motor driver, because it runs higher voltage, higher current. So I can't do that right now because the 12-volt's not connected. But if I wanted to do this, I would put the ground... Oh, I don't even know now. I am so confused. Okay, anyways, the key thing are the foot switches. So right now, which motor is selected? I should be on the one I want. Display page, here we go. So I'm on the 5 kilowatt motor right now, which means the 10 kilowatt should have a connection. So let me see, if I switch the motor select. Okay, that went to 3 volts, meaning the ground is connected. Now when I hit the E-stop, that should drop back to 0. And it does. Now I should have no voltage on the other 5 kilowatt motor. Why am I seeing 2.6 volts? I'm seeing 2.6 volts no matter what. Okay, what am I doing wrong here? 2.6 volts would be 3.3 and 5. This pin is not set up properly. That yellow goes to 4th pin up. The fourth pin up is CN9. 4 is PB3. PB3 is foot switch 5K out. PB3 is foot switch out. How do I have this configured? As an output pin, no pull up and no pull down. That has to be the same as PA9. PA9 is no pull up, no pull down, no pull up, no pull down, low, low. So those are configured the same. The 5 kilowatt is PB3, which is correct. What am I doing wrong? So here's the foot switch configuration. The 10 kilowatt is working, the 5 kilowatt is not. The 10 kilowatt is PA9 and the 5 is PB3. So let's find where the 10 kilowatt is configured. Main.C 507, and that's for GPIO A. B has the 5 out, so that's in the right place. So it's on GPIO B, and this translates to the GPIO pin 4. This is the section of the code where the pins are actually configured. So the 10 kilowatt is working, and it is output PP, no pull, speed frequency low. And that is for GPIO A. So I need to find GPIO B. The mode output is PP, no pull, frequency low. My speed high switch is there, speed low switch is there. Okay, I'm missing the foot switch. 5 kilowatt out pin. Now, do I have that somewhere else, or did I just forget to put it in there? Looks like I just forgot to put it in there. Okay, so that might have fixed it. Okay, and now I've got 0 volts. Oh, I gotta switch my page again. Okay, so right now the 5 kilowatt is enabled. Those are the switch states though. Forward 20% to the 10 kilowatt motor. So if I do E-stop, 0 is still 0. So 0 volts means don't use this motor. So flip that back on, and now if I do my motor select, that should go to 3.3 volts. 3.3 volts. Now I should see 0 on the 10 kilowatt motor's foot switch. I do. And if I switch the motor back, it should go to 3.3, flip the E-stop, and it's off. Okay, the motor stop is working. That was the key part. Now, let's look at the speeds. I need to switch to the speed. Slow speed, medium speed, down to 0 for turbo speed on the 10 kilowatt motor. I love this LCD so much, it's amazing. So right now it's not selected, so it should go to 3 volts when I go from turtle speed to slow speed. Turbo, there it goes, it's working. Okay, so the 10 kilowatt is fine. Now, the switch state is allowed to pass through, 2.5 volts. That makes me think I cocked that up again as well. 5 kilowatt motor. Why did it jump from 2 to 3 volts? All right, I think I might have damaged my STM32. I'm waiting to hear back from friends to see if I actually did or not. The GPIO input pins are supposed to be tied to ground, and I had it tied to the 5 volts. So when I closed the switch, I sent 5 volt into the input pin instead of tying the input pin to ground. So that might be why the high speed and low speed select are not working. At this point in time, I'm not going to worry about it. The key thing was that the foot switch was working, so that when one is selected, the other is turned off. I'm going to re-verify that that's still working, and then we're going to get back to wiring this, because it's already 20 to 6 on Sunday. I wanted to have all day Sunday to edit this video, but projects don't care about your schedules. I have a second STM32, but I don't want to try moving all of this. I'll just as likely damage something else. The reason I say that is I was looking at the switch state in the logs. In the serial output, I have the menu that shows all of the switch states. And I was noticing that the 10 kilowatt high speed and low speed were being selected properly. I could change them and see them go from 0 to 1. The 5 volt was, or the 5 kilowatt was always 1, no matter what. It was ignoring the switches. And I went through and I took my time to make sure that everything was configured properly, and it was, save for the wiring accident. After all this time, I had managed not to do anything wrong with my wiring, and I finally screwed something up, and it's taken a little bit of the wind out of me, but I mean, this was inevitable. You don't start something like this without damaging it. Yesterday when I sat down to start filming this, I honestly thought, I'm not going to have a lot of material for this video. It's going to be a short one, because I honestly thought I was going to come here, wire it up, spin the motors, call it done, have the rest of the weekend to finish editing this video. Somehow, I never lose my optimism. Okay, I may later, I'm going to wire everything for the high speed and low speed to the 5 kilowatt, and I just know that that's not working for now. I'll keep the camera rolling while I do my first crimp, because I've not crimped these style of connectors before. And once I know that that's working, I'll turn off the camera, do the rest of them, and bring you back. The first one is the coils. So here, I have these running 2 pins. I need to cut these off and run them in. On 2.3-11, the first pin 6 is return. It's marked as a ground, but that confused me a bit last night because it's not actually a ground. What it is, it's either side of the contactor. So this here gets power when the switch is closed. This switch here is closed. This closes when the contactor closes. Coil positive is key switch, which is the red one. They call this the red one the key switch because it's downstream from this. This is normally what would have been the key on the boat. These little connectors that came with that kit, they break so easily that I've actually got one stuck in my new breadboard I couldn't get out. So I don't like them and I'm not going to use them anymore. Okay, so the first thing I need to do before I forget is put a boot on this thing. So I'm assuming I can just push this through. Okay, this silicone wire is really flexible and doesn't really want to push through. Can I twist it on? Oh, this is going to be a fight for all of these, isn't it? I'm sure there's a tool that inserts these. You know what might work? One of my pin pulling thingies. Some of these are tubes. I wonder if there's a tube that is just big enough to insert this wire. That one might do it. If that's the case, then I want to pull it through this way. Can I get this? All right, so there. I don't know if you can see that, but I'm hoping to use this like a thingy to pull. God, I'm doing such a good job explaining things today. So now what I'm hoping to do is... Haha, it worked! That's awesome! Okay, that makes me happy. I'm getting back into a good mood again. Now this wire is really, really narrow compared to the size of this. So what I'm doing, let me zoom you in so you can see what I'm doing here. I have no idea if this is the right way to do it. Let me be very clear. There are 2 levels of crimps. The larger wings go around the insulation of the wire, and these inner folds grab the actual conductor, I think. Obviously, I don't have the right tool for this, so I'm just going to use needle and pliers. It's the crimping version of a butter knife. Now, I think maybe I need to pre-crimp this a little. What I'm doing is I'm just flattening it out enough that I can still shove the wire in, but once it's in, I can just crush down on it and just push it down. Sorry if my head's blocking you. My eyes are garbage. Okay, I know you're not supposed to twist these, but I think twisting them is not high on the list of things I'm doing wrong right now. Okay. Remember, this is a signal wire. It's not pulling a lot of amperage. Okay, I'm worried they might have spread out too much at the top, but let's see. So ground is pin 6, and pin 6 is top center. So looking at it like this, with this wing to my right, it is top center, which is this pin right here. No, I didn't make it too wide. Good. Before I clip it, I want to pull this down some so that it seats in. I heard it click. I wanted it Can I get this boot down? There we go. Probably should have pulled that boot tighter in so that this didn't latch and I could grab it with the pliers and pull it, and that would seat this and pull it in. So it would basically pull that back. But you know what? For my very first try, I think that's okay. All right, so there's my first one done. Let's try that and see if I can be a little bit more elegant with the blue one. Red one. Oh gosh. I should mention that for whatever reason I haven't turned on my air conditioning and it's 27 Celsius in here right now. Why have I not turned on my air conditioning? Because I've been too hyper-focused on this and my ADHD doesn't let me do two things at once. Why did I do that before I should have done that after I put this on, but that's okay because I'm going to try that trick again where the key, there we go. Okay, that's in. This tool, I don't know if I had it in camera shot, but this tool is totally worth it if only to put these boots on. There we go. And the red, I almost want to pull that out just to sink this in. I don't like that it's sitting up some. I wonder if I can I use this to push the rubber in? Okay, you know what? These tools are very quickly becoming amazing in my mind. Brilliant. Brilliant. Okay, red is the key switch, which is pin 7. Pin 7 is the bottom side. 6 was top center, 7 is bottom center. Okay, so I'm going to pull this down further so that it's starting to go in. And it still wasn't enough. Okay, well, you folks who told me to get this, thank you. Thank you so much. There, this one. I don't know if you can see, but it's got a little bit of a hook on the end. And I'm using the hook to sort of get around the side and the flat part to push down on the rubber part. I really hope that made sense. All right, so I'm gonna take this, give the rubber a little bit of a push. I'm calling it rubber, it might be silicone, I don't know. There's gotta be a more efficient way of doing this, I am sure. Okay, first 2 pins done. Now I should do the same thing to this side. I'm starting to think I'm not gonna spin this today. Sometimes projects just hit lulls and you just have to keep making progress, even if it's just a tiny bit at a time. So black is top center. Actually, I'm going to try pulling this down all the way this time, right to the root. There was no point doing that because this came back anyway, so I'm going to need to press them in each time. I think that is unavoidable. I'm sure somebody's watching this is very familiar with how to put these in, and it's like, no, do it this way. Put it in your comment. Save me from myself for next time. But for now, I'm just doing it the way I can. I was talking before about not sure how long I wanted the leads to be. I'm not worried about these because these are always going to be close to the controllers. It's the ones that go off to the helm that have to be longer. I don't think I have enough wire to do them 9 feet each at this point. The spools, I looked it up afterwards, are 25 feet per spool when they were new. And I don't know how much I've used. And I don't want to run out right now, so I'll just live with the fact that I might have to splice them. Key switch is the bottom. Coils are done for both of them now. Camera battery's almost dead. I'm going to plug everything into charge, get my day job done, and then come back to this and see if we can finish wiring it up. Hopefully by the time I come back, I'll have an answer as to whether I likely damaged the STM32 or not. Learning is fun. Learning is also other F words. Okay, back in a bit. So I screwed up twice when I updated the code. So I've got the screen recording going, and you'll probably notice that there's more pins. When I reconfigured this to use an address pin, the DACs have 2 addresses depending on whether a particular pin is pulled high or low, A0. To make it so that I would select which DAC I wanted to talk to by pulling its corresponding A0 pin, high or low, I don't remember which, and then send a message onto the I2C bus, and whichever DAC had been asserted, I think the term is, it would talk to it and do whatever I wanted to do. Those pins were output pins set to control addressing the DACs. And two of them were the ones I tried to use a second time for the switch. Now, the problem is I screwed up twice and the switch should have been tied to ground and it was tied to 5 volt. So I probably sent 5 volt into pins PB8 and PB9, which are the 5 kilowatt throttle and regen. I have to move the wiring for high, mid, and low speed select for the 5 kilowatt over to the new place, and then I need to run my testing again to see whether the DACs still work. I mean, the DACs are fine, but if I fried the pins, I don't know. I'm trying really, really hard to get back to a weekly schedule, and it's just, the fates aren't having it right now. If this was a TV production, well, first of all, who the hell would invest in it? But second of all, you know, you'd have all this high-spence drama. Oh, are you going to make it? Are you going to make it? And then behind the scenes, you have a whole team to help make sure you make it. I don't. If I screw up, things fall behind, and that's just that. I'm at that stage of learning a new thing where I feel like I should know better, and so I get mad at myself for my mistakes. Okay. So now, in theory, that's wired up properly. I need to reprogram it. All right, let's see if I can undo my cock-up. So the first thing I'll do is I'm going to see if the switches are working, and then I will test the DACs. Okay, the 5 kilowatt and the 10 kilowatt are both reading 0 now. If I take the 5 kilowatt, oh my god. Okay, so that was my problem with the 5K speed select. Now I need to measure my DACs. Okay, so let's, oh, I hope I didn't screw up the DACs. Again, not the DACs, the output pins, the address 0 pins. Starboard throttle set to 5 kilowatt motor. Okay, so let's go to the 10 kilowatt motor. That is ground, and let's tie this to hot. And I have 3 volts, and it's at 52%, 20% forward. Okay, the 10 kilowatt DAC is working. Now, what about regen? Oh, actually, hold on. Before I do that, I want to make sure that switching the motor drops this to 2.5 to make sure that's still working. So right now it's on the 10 kilowatt. Bam, 2.5. Back down. What if I do the e-stop? E-stop ramps. I need to get the ramping out of e-stop. But that's fine. It's working. This is the regen. Okay, the 10 kilowatt motor DACs are working. But that's fine. I don't think I screwed those ones up. It was these two DACs that I think I screwed up. Let's move this over to the 5 kilowatt. This is the test. How lucky did I get? Motor, so it's putting 2.5 right now. I switch to the 5, and it drops to full reverse. This dumbass got lucky. When I realized what I did, I was sure I destroyed this thing. Oh, wow. Okay. When I dropped back to the, so it went to the 5 kilowatt, and it's working. So let me go do the e-stop. E-stop. It ramps, but it goes down. Okay, so perfect. Put the e-stop back on. So that is working. Now let's look at the regen. Oh, fuck. Okay, that was the... You think after all of that I would be more careful about not putting the +5 into the ground, but there you go. Right. Regen is working. This is me being very relieved right now. Listen, points for the Nucleo board. It's at least idiot resistant enough to resist this idiot, so... Okay, all right. Okay. Now I can get back to cabling this. Ugh. Actually, no, that calls for a cider. Ah! All right, well, I just checked because I noticed OBS's background hadn't changed and it wasn't recording the screen. Sorry for that. Okay, so from 2.311, which is the one I've already started, I have 3 more wires that have to come out of this. And they go to the outputs of the ULN pin. That's the foot switch, high speed and low speed. And I've got blue, green, and the 12 volt is red. Now, I have to think because most red is, oh, you know what? This is 48 volts. So I've already screwed that pooch. Okay, so I'm gonna run, what colors do I have available to me? I'm gonna run brown for the 12, do I wanna run white for the 12 volt? White is neutral. Oh, but it's hot in DC also. What color should I use? Oh, okay, this is a question. I can get 12 volt from one controller or the other. Can I connect the 12 volt between the 2 controllers together and feed them into the same pin so whichever one is on, this chip is energized? Or do I need to put a second chip on and move these 3 wires over to that chip and its 12 volt goes to the second chip? Okay, this is for sure ULN 2003. Okay. This breadboard's full, so I'm going to have to take this and move it to another breadboard and jumper it and move these over. I took the ESP32 with me when I was doing my crossing, and when I had some downtime I was reading up on how to do Bluetooth, and I learned a bit. That's for a project that's coming down the road. So originally my documentation, I had 1, 2, 3, and then the corresponding, was it 16, 15, 14. The 10 kilowatt was on pin 1, 2, 3, and the 5 kilowatt was going to be on 4, 5, 6. I'm keeping it 4, 5, 6 on this one. The reason why I'm worried that this might not work is I'm worried that the 12 volts, there's got to be a buck converter in the actual Kelly controller. And I doubt that the 2 controllers have created the exact same 12 volt. That's probably fine, but in theory, one would feed into the other. And I mean, maybe it's not an issue, but I'm a little gun shy right now. And now I need to bring the 12 volt from the 5 kilowatt into here and the 12 volt from the 10 kilowatt into here. I think I'm going to do 3 feet on the cables. Does it really even matter at this point? So this is going to come in like this, and these have to come back this way. And I've got brown, blue, and green. You know what, I can always just call up Golden Motor and say, hey, listen, can I buy some more of these connectors and just do them again when I get the boat? So with that in mind, I think that is long enough. So I have to make 2 sets, one for the 5 kilowatt and one for the 10 kilowatt. For this first set, I'm going to put the ends on exactly like you already saw me, so I'm going to turn off the camera. I won't press them in yet. I'll get the other side done with the JST connectors. Just have the cables ready and then I'll bring you back. So I was cabling this up and I realized I was looking at these pins, the male pins, but really it's these male pins. I have to run these to the female pins, which means I crimped these wrong. Remember I said I had 1 spare each? I can't win for losing today. Thankfully, I'm not using all the pins, so I should have enough spares. I wanted a challenge. I got a challenge. All right, I'm going to fix this, and I'll bring you back and I'll show you everything I did once it's fixed. All right, it is now after midnight. I thought I was going to be done around 10 o'clock yesterday. So this is going to go into day 3. Oh, strong shadows. It's because I got that light on. Anyways, I had a problem terminating the wires. And I did a tug test and one of them pulled right out, even though I crimped onto it really hard. And when I looked at it, I could see that even when it was crushed down, there was a bit of a valley and the wires were caught in it. I don't know how Kelly mounted them because, oh, this light's too bright. I don't know how Kelly mounted their wires because I'm using 24 gauge and it just barely fits through the waterproofing boot. So I have, and their wires look even smaller than 24 gauge. So I'm almost wondering if they soldered them too. Like the connectors look like they're meant for like 14 gauge. Anyways, What I'm doing right now, more for mechanical anchoring, I'm putting solder on the connectors. And I know that that's a bad idea for any kind of movement because eventually the solder will break. But the way I look at it is I've crushed it down dry and it is making a contact. I am using the solder just to give it that little bit more of an anchor. If I ever have a problem on the boat, I mean, in a real pickle, well, first of all, I've got 2 motors, so I can just switch over to the other motor. But if I had to do a field repair, I could also just take the broken wires and just put them together with shrink tubing and call it a day and just not even have the connector there. I would like to have smaller waterproofing Deutsch connectors, whatever they're called, something that's designed for this small gauge of wire. I'm not really happy about what I'm about to do, but I'm going to show you what I'm about to do. Well, I did it already to these ones. All of the female connections are done. Now I'm about to do all the male connections. They soldered fine, but because it's a fairly big chunk of metal, I couldn't use my standard soldering iron. So I broke out the big gun. So it's not enough just to flow solder into it. You need to heat up all of the metal so that it actually binds to it. Because I'm trying to heat it from underneath so that by the time it melts the solder, it's doing it because there's enough heat that's come up through the connector and into the wire to actually melt and flow solder. I can do this because this is silicone wire. If this was your standard, like this cheap patch cable, I think it's ABS or whatever the plastic is, it would have just melted under this heat. So I got kind of lucky that I used silicone wire. The other thing too is by clipping this here, it means some of the heat's going to come down here rather than coming into the wire. So I'm telling myself stories so that I feel less bad about what I'm doing. Get up underneath it. I put a touch of solder on it just to help get the temperature to flow or to pass into the pin. There we go. There you go. And just keep doing that until I'm done. Day 3 of what I thought was going to be a few hours on Saturday. So let me show you what I've got done so far. So I've got all of the male pins done, and I've got the other female pins done. Before I install all of these though, now that I can know that these can be tugged out, I'm going to pop these out and do the solder like I did yesterday. And thank you again to everybody who recommended these. They have come in useful in ways I would not have expected, especially putting these boots on. I also found that I could only run this for so long yesterday, and then it seemed to just shut itself off. I'm assuming it overheated. I kind of want this up higher. There, that'll do. Not at all precarious. Reason is this has got an angle to the flat, and I want that to be able to touch at the bottom of this to transfer as much heat through. And if anyone's wondering, yes, this is lead-free solder. Come on, Maddie, this is your last one. Don't cock this up. There we go. So I'm gonna let those cool down, put all the solder stuff away, and then get the laptop down so I can figure out which pins go where, and let's finish wiring this up. Everything is cooled off. Now it's time to get back to wiring things. Also, I figured out what I did wrong with what I did wrong. I figured out a way to make OBS more reliable. When I stop one record and start the other, it just leaves whatever the last frame of the last recording on screen. I don't know if it's a bug or if I'm doing something wrong, but if I close OBS and restart it, each time I want to do a screen record, that seems to work more reliably. So hopefully from this part forward, I'll have more reliable screen shares. I have to again remember that I am looking at the inverted components. These here, the headers, male, female, I don't want to make the mistake I made last time. Actually, before I start, I have to think about the colors because there's colors that correspond to the wires that come from the Kelly controller that are documented in the Kelly documentation. I don't have matching colors, so I have to create another column where I have Kelly color separate from Maddie color, M-Helm color. So I'm going to call this Kelly color and M-Helm color. So the first one I want to do is pink and black. The 2.3-11. If I go to plug this in, bottom center is pink, top center is black. Now I noticed with this one, I can't push it in all the way, and yet again, one of the pins from the set that I bought comes in really handy because it's got a little bit of a hook on it, which makes it perfect for snagging onto the back of the metal shield and pushing it in. And the bottom one is red from the same motor controller. All right, now you've had the close-up of seeing how this go in. I don't want you to be just looking at the top of my head for the rest of the video. Now I have to look at my other cables here. I have 3 more cables for each, and I've made a brown, blue, and green. So I have to decide. So black goes to black, pink goes to red. I had a 12-volt red. I should have used brown for pink. Well, you know what? It's too late. These wires were done a long time ago, so that's what it is. So red is going to go to brown. What other 2 colors do I have? So white will go to green and blue will go to blue. So those are the 5 pins that are going to go into each of these 2 connectors. I'm not connecting them to the boards at this point. I'm just going to leave them raw, and then I'll figure out how to braid them or something so that they don't all over the place. Red to brown, red to brown. Yep, that's right. And this is the 12-volt line. Years ago, I had an opportunity to take my father and his girlfriend to Japan. For those of you who saw the GoFundMe appeal after my dad had his heart attack, you probably saw some of the pictures of when we were over there. When we were over there, it was one of the only times I've ever, when traveling, hired a tour guide. A little town called Takayama, Tall Mountain. It was a town that had decided to, it was far enough away from all of the major cities that it wasn't damaged during World War II. One second. Next is white. Green goes to white, which is forward, which is 12, which is top white. So white goes to green. This town, like so many towns around the world, was dying. All of the young people had left looking for better work in cities. And one of the things they did to try to save their town is they intentionally made themselves a tourist destination. They played up all of the classic foreigner ideas of what Edo Japan would have been. They buried their wires underground. They tried to really lean into the fact that a lot of their old architecture survived the war. If you wanted to be a tour guide, you had to live there. You had to be from there. And then they put these tour guides up for hire for tourists. And I kind of wanted to give my father and his girlfriend a proper Japanese experience. We stayed at a ryokan, like a traditional hotel with a tatami mats that you rolled up and the onsen, just classic, stereotypical Japanese trip. And the one day I hired this guy to take us and show us around, the guy we ended up hiring was a retired history teacher at the local high school. So he was showing us around, and then my father got a bit tired, so him and his partner peeled off, and it was just me and the tour guide. And we went to, I can't remember the name of the place, but there's like this historical park. They took a bunch of old buildings that were going to be torn down and took them down meticulously and reassembled them in this area so you could see what the houses and the barns and stuff were like in different periods through the past. Blue is Eco directly below it. And we started talking. He was talking about how the Matsuri, they no longer had enough young people to do the festivals. Matsuri is festival. And all Japanese towns, or most Japanese towns, had their own regional Matsuri. And they had to start hiring university students to put on the Matsuri because it was part of this tourist attraction. And he was kind of lamenting how it wasn't really how it was when he grew up. When he grew up, there was local people that lived there, and the Matsuri were all done by local people. It was their community celebration. Now it's a show. And I told him how I felt a little guilty because, well, I kind of did the same thing. Like a lot of people of my era, I left my hometown looking for work. I came to Toronto swearing I'd only be here for 2 years. That was in 1995, 29 years ago. Anyways, I told him about how I felt guilty for leaving and how I was really impressed that Takayama didn't try to hide it, and they decided that they were going to come up with a strategy to save themselves, and I thought that was brilliant. And I talked about how my hometown was kind of dying. Dying, not in that there aren't people there. Last I checked, there was like over 200 houses in this little island I grew up on. It used to be, we were the 20th house. But what made it special is gone. It's just another suburb of another North American city, and that's fine. Societies change. But you can't help but feel nostalgia or sadness that the society you grew up in doesn't exist anymore. I tell you this because yesterday I got word that an absolute legend who used to live on my street, his name was Bev. His wife's name was Faith. Bev was, if you ever watch any interviews of Maritimers in the 70s and the 80s, they have a way of talking, they have a way of dressing, a way of behaving that now might seem a little cliche, but back then was totally normal. But I remember as a kid thinking he was a little old-fashioned. But you're a kid, you know, you don't really think about that kind of stuff at all. And he was like a classic Maritimer, like as stereotypically Maritimer as you could get. And he passed away yesterday. He was born in 1927. It's 2024 now. He lived to be 97 years old. Should we be all that lucky? And he was healthy right up to the end of it, too. So it's not that he didn't have a good life, it's just he was one of the last of the old guard. With his death, a little bit more of the culture I grew up with has died. And he was an amazing person, and I absolutely mourn him. And when I was down when my uncle passed, my father and I went for a visit and had a beer, and it was a good visit. Anyways, I've been full of all my childhood memories. Him always teasing. We have a thing in the Maritimes. If someone's not teasing you, they're mad at you. If someone's taking the piss from you, then you're on good terms. It's all good. He delighted in telling stories to me and the other kids. Just the silliest stories to see how long he could go and how silly he could get before we realized that he was having us on. But at the same time, every time I'd have a flat tire on my bike or a chain broke or something, I'd go knock on his door. He'd come out into his little shed and he'd fix my bike up and we'd talk for a little bit, and it's kind of like the neighborhood grandpa. I mean, when I was a kid, he felt like he was 100 years old. Anyways, Bev, you're a legend. Okay, and with that, the two female connectors are done. Are they wired properly? I'll check that in a minute. Now I need to do the male connectors. Now these ones, the pins go in the back. So if I hold it where the pins go in and I hold it over my screen, the alignment's the same. So top center is green, top left, 3, 15. Total center is 8, center left is 20, and then bottom left is 4, 2, and 11. So as before, I need to assign colors. So I have on this side, white, black, red, brown, and yellow. So I've got 5 wires. So both sides have 5 wires as I'm configuring it. So I have a brown, so we'll do brown to brown. I have no green, purple, dark gray and red are not used, gray and black. Okay, so black will be black. So brown and brown, black and black, and now I've got white, red, and yellow. I'm going to do green to yellow. Purple will be red, and gray, actually gray should have been white. Oh, cool, that's what it is. So brown, yellow, red, white, black. Okay, now I've got those ones set up. For a lot of reasons, I've been thinking a lot about mortality lately. Such a happy topic, I know. It'd be a hell of a thing to make it to 97. If I made it to 97, I would live to 2074. Jesus. But even more than quantity, I think it's quality that matters. I had a good conversation with a friend of mine, one of my best friends from a long time back, about being on the boat and the risks coming across with it. I spent a lot of time thinking about this when I was on passage, thinking, you know, this little adventure could kill me. Obviously, I'm doing everything I can to make sure it doesn't, but it could. The older I get, the more I think that it's better to take chances and potentially die young than to live a long life and not fully enjoy it. There's Maddie's philosophy for the day. It's entirely possible I'm going to redo all of this when I get on the boat, and if I do, I'll sit ahead of time and think about all the colors I want. Like once everything's finished being built, I can sit down and look at all the wires and create a table of which colors would be ideal, and I'll make sure I can match the cable colors from there to the board. I have to come up with a standard for the switches and stuff anyway, so it's all going to get redone. Red and yellow is done. What's my next one? Red. Maybe when I'm done, if this actually works, I'll make this a kit. I'm going to sell merch, might as well sell useful merch. And the last one is black, which goes to pin 20, and pin 20 is center left. Let's check these. So this goes to here, black goes to black. That's good. So white to green, I don't know if you can see that, but it's white. So that one is good. Blue to blue, 22. Yep, so that's good. Pink to red, that's fine. And the last one is brown, brown to red. Okay, so for sure, this one's good. Now this one, gray to white, gray to white. So that is good. 20 is ground, black to black. That's fine. And the next one is the red, which is going to purple. Purple, I know you can't see that behind my hand, but purple to red. And then I've got yellow to green, top center, green to green. So the last one now is brown to brown, brown to brown. So I know this one is good as well. Now that I've got this one as a template, I can quickly knock up the last one. So I'm going to push the waterproofing thingies down. Then I am going to terminate, I'm going to probably braid them so the wires don't go all over the place, kind of like how I did with this one. And then I'll put the JST connectors on it, and I'll bring you back when I'm ready to start running the leads into the boards. So I will be right back. I think this is going to go into a day 4 because it's already 9:30. However, it takes what it takes. So I figured out a way to dress the cables, and I wanted to show you how I did it with this one. So clip it into anchor it. I looked up how do you braid your hair for 5 strands. Basically, you take your 5 strands, start them in, doesn't really matter what particular order. You go from the left, you go under 3, and then over 2. And then you take the opposite side, you go under 3, over 2. So now the white is the outside, so it goes under 3 and over 2. Now the red is the outside, so it's going under 3, over 2. So I'll name the colors this time. So I've got right now brown, red, black, white, yellow. So under 3 brings the yellow to the left of the red, and then over 2 brings it over the red and black to sit beside the white. Under 3, over 2, under 3, over 2, under 3, over 2. Okay, you know what I'm realizing is helping? If before I do it, I think about, I'm going like right now, I've got red, yellow, white, brown, black, and I'm going to bring the red under. So I know that I'm going to bring it under the brown and over the white. So I bring it under the brown, over the white. And now before I lose it, I know my black is my next one, so it's going to go under the red, over the white. And I think that's where I'm going to stop it. So what I've done now is I've got about that much to work with. And this is fairly tight, so it's going to loosen up over time and average out. I had a zip tie. Okay. And now I just dress the ends like I did all of the others to put the JST connectors on it. And they're done. I ran all of these cables to female JST headers. And I did that because hopefully before too much longer, this mess of a circuit board, which I realize is just out of camera, but you've seen it many times before, is going to get replaced with an actual circuit board. I've got some more development I want to do. I want to move all the switches to a parallel to serial multiplexer so that I can free up some of the pins. And I need to free up some of the IOs for some stuff I want to do. And I want to get that done before I get the first circuit board made. Basically, hint to what's coming. I mentioned that I was playing with the ESP32 when I was on the trip with Reese. I decided that I want to make a display module, so the compass rose, the throttle position indicator and whatnot are going to be, and the key switch are going to be modules, probably on an RS-45/CAN bus. So I need to free up some pins so that I can actually communicate on that RS-45 bus. Oh, I also want to add a second screen. Oh, you can't see it, but you know that the LCD screen, I want to add a second one of those so I have to free up some pins. Point is, I've got these as female connectors because on that circuit board, I'll just have headers that I can plug into. But that means that right now, because I'm going female to the breadboard, which is female, I need to make some jumpers. And I also have to think about where they're going. So let's do that now. All right, so I have to be mindful that first I'm starting with a 10 kilowatt. I'm gonna set this aside. Run that ground to there. So black is ground, that's done. Foot switch is white. So the foot switch comes to the other side of the ULN. You know what, I'm gonna do both of these at the same time. So the ULN pin has a ground going to it, so I'm just gonna tap off of that. Okay, so the grounds on both are connected. So white is the foot switch, which goes to yellow. See, this is why I need to redo my colors, because what I've got is to white here goes to yellow here. So now do I do white to white, or do I switch to yellow right away? So I'm gonna have the colors changing all along. I really need to redo this properly when I do the circuit board, but that's fine. Oh, this is gonna be confusing because I have a yellow. Damn it. All right, well, whatever. This is why you prototype things. I'm gonna use white. This is coming to ULN pin 16 for the 10 kilowatt. 1, 2, 3, 4. There we go. So that's the foot switches done on both of them. Okay, so brown goes to the regen, which conveniently was actually brown. Now, this kit doesn't have brown, so I'm gonna use purple. Yep, there's definitely gonna be a color coordination section of this build later. Now, the other side is ground, which I've already got, so I don't have to worry about it. Totally not sketchy at all. Now, this isn't gonna mean anything to you because I'm gonna edit this all together, but for me, I'm not trying to spin this tonight. For historical context, this is after the weekend of CrowdStrike, when it took, I think Microsoft said 8.5 million machines offline last Thursday. I'm a Linux admin hosting Windows servers. Thanks, CrowdStrike. So yeah, I wanna make sure I get some good sleep and review this. I've talked about this in the past, but I wanna make sure I've got good sleep before I try to do anything too crazy. Okay, so regen is connected on both motor controllers now. So the next one is yellow. Is green, which is throttle, which is the DAC. I've got red to yellow. Okay, whatever, I'm using yellow. Once I spin this, I'm gonna do a little mini video for the patrons because those people are so kind to support me and there's been so much time between videos. I'm kind of feeling a bit like Cody's lab. Really struggling to maintain a release schedule, but projects take the time that projects take. All right. And the last one is red. Red is purple, which is 5-volt output. Feed to throttle DAC. What the hell is feed to throttle DAC? Okay, I'm definitely not spinning it tonight because I'm gonna have to read up on that, but I think I went through and I marked everything as no contact if I didn't need it. Feed to throttle DAC, pin 4. Anyone ever watch The Dark Crystal? The Skeksis? I'm still the Emperor. 80s kids just, everyone else, what the f is she on about? So, on the other one, brown is 12 volt, isn't it? Yes. So this feeds the ULN 2003A Darlington array. I don't have brown, so that was going to be purple, but I've used up all my purple. Do I have any purple left? Tell me this isn't like Lego. Oh, where's the 2x4 piece? Oh, I miss being a kid sometimes. So the purple goes to ULN 2003A pin 9, which I believe is this one, the top right-hand corner. But let me switch over to the other one to verify. Pin 9 is common, yep, so that one right there. Okay, so green and blue, and these are the right colors, I believe. Green to 15 and 2. Oh, wait a second. That's probably the worst possible mistake. Blue on the ULN 2003 goes to green here. Oh, bollocks. Oh, but that's actually how I wired it because I'm an idiot. I failed that task successfully. I am so going over this again. I don't really feel like I've wasted time though, because Man, have I learned a lot having to think this through. And when I have to go back and do something like over a second time, like I'd forgotten how I wired this up the first time I did it with the Arduino. The process of reading through all of the documentation to figure out the pinning again is kind of useful. It helped it stick in my head better. And one of the biggest goals of me doing this is that I want to be able to fix my boat out at sea if anything goes wrong. So doing this a couple of times is a great way to get things to stick in the head. I'm now racing to finish this before the battery dies. So purple into common, and then the blue and green are backwards. And voila! Barring mistakes, tomorrow after work, I'm going to go through all of the wiring, double check everything, make sure everything is still connected, and apply some power. For me, that's on the other side of tomorrow. For you, day 4. Let's go. For you, that was this finger snap. For me, that was actually 2 days. I might have bumped some things. Before I power this up, I want to fire this up and make sure that I'm still good at getting expected values out of the DACs and out of the switches. Oh, see? That's exactly what I mean. That's popped out before. I'm going to take a bit more insulation off that. I posted a picture of this on the Patreon, and the general comment was, that's an impressive rat's nest, and they're not wrong. This will all get reworked off camera later to make it pretty, but yeah. Anyways, let's get back to it. One of these days I need to get a 4K camera so that I can film from wider out and just zoom in and post easier. But I can't do that yet. Right now it appears to be mostly working. So I'm going to flip the E-stop. So now neither motor controller should be getting a signal. Do I want to just turn this off entirely while I power that up and configure it? I think I might. How do I want to do this? I've got the laptop out. You're not going to be able to really see it, but I'll try to make sure I get OBS recording. Okay, so I have my programming notes from last time, which you're probably seeing right here, and I will use those to program this now. Now it's time for me to turn on the batteries. Okay, so first things first, run the pre-charge resistor. 1, I heard them both boot up. Contactor's closed. One of them's not happy, but why did that motor spin up? Okay, well, I probably shouldn't have had that so close to there. Why did that spin up? Okay, well, whatever. Now we gotta connect the serial cable. I definitely am glad I turned off the controller, because otherwise I would have thought that that spinning was my fault. Okay, I know there's going to be voltage through the pre-charge resistor, but does that mean the contactor is closed? It must be, because this spun. I don't know if I just opened or closed the contactor. Let's bring up the Moto ES. It should come up, I believe, as COM3. Yes, the motor's not being used. COM3 opened. Now, it's been a while since I used this, so I'm trying to remember how to use it. Parameter? There it is. Set the low voltage to 40 volts. Okay, 40 volts. I'm going to do a write after each operation. Write success. Am I going to have to bring up the parameter every time? Yes, I think I will. Okay, I'm not going to write on everything. Set overvolt to 58.4. 58.4. Identification angle. When this shows 85, the controller thinks the motor is configured. Set this to 170 in the configuration, write out the new value, wait a minute, and then turn off the controller using the key switch. Wait a minute, then turn on the controller with the key switch. The motor will move periodically. When the sequence completes, it will start sounding the internal reset, 3 beeps, 2 beeps, repeatedly. Power off the controller, wait a minute, and turn it back on. Load the configuration from the controller and verify the values are back to 85. Okay, I'm not going to worry about that right now. These are all my notes. Where did I write down what I wanted to actually set? Coming back to these documents after a while is actually a good thing. It's making me realize that they're not that good. One of the whole points of being able to build all of this myself was so that if anything breaks, I can fix it myself. Well, okay, but there's no way I'm going to remember all of this 2-3 years down the road when something goes wrong. Coming back and rereading my notes after having a bit of time away, it's making me realize how much I've forgotten and how unclear the documentation are. I'm going to rewrite this so that it's more clear, so if I have to refer to it in the future, yeah, I can just read it and know what to set. Dead low, set this point, set to 5 for 0.25 cut-in voltage. Oh, it's 0.25. I'm going to have to change the range on this. I thought it was 0.05. Okay, that's fine. I want to change that to 5. TPS dead high, I'm changing it from 80 to 95. Brake sensor type for regen mode, 1 equals 0 to 5, 2 equals Hall effect, use 1. So brake sensor type, okay, so I want to change that to 1. Max speed, maximum RPM allowed. Ooh, right, this is going to be good when I go to set, once I know what the ratio is for gearing down, I can set this so that the controller won't let it go fast enough to cause cavitation on my propeller. But for now, I'm going to ignore that. 3-speed mode. Disables FNR. 0 is 3-speed disabled FNR mode. 1 equals 2-speed mode. 2 equals 3-speed node. Yeah, change to 2. Startup brake release. Oh, right. Okay, so this is if you try to turn on the controller while the throttle already has position. It won't automatically start spinning the motor until it sees the brake pedal pressed. We're not using the brake pedal, so probably better to leave it disabled. So startup brake release high. Brake dead low and dead high. I need to change that to 5 and 95 as well because that's the regen limit. Okay, this overheated last time, so I'm going to pause this for a minute and let it cool down. Max reverse. Oh, max reverse speed should be 100. I think max reverse has to be 100% as well. Oh, there's my mid-speed forward, mid-speed reverse. Make that 50-50. I should check these values on the other controller when I'm done. Low speed is 50. That's the ramping built into the controller. Okay, so where's the joystick function? Motor temp sensor, I think I want it to 1. Okay, we're setting our motor to cut out at 95 degrees Celsius and resume at 80, just because I don't have the active cooling on it yet. High temperature cut, drop to 95, so I don't burn myself, and resume is 80. Where do I set the joystick mode? That's the most important part. I'm going to have to write this and then load the other one and see if what's here is actually different. Okay, the most important one is setting the joystick mode. Okay, I'm going to write what I have so far. Write success. Is there an actual joystick function here that I just can't see? Forward HA, forward A. Oh, it's an over here. There it is. Oh, bloody hell. Okay, right. I think I've got it. What I'm going to do is move this over to the other controller, load the values, because I know that was working before from the last time I did this. I'm going to take a picture of it and then switch back and I'll compare the settings. What? Retry. No power. Oh, the contactor might be off. And the program crashed. That's a good sign. Why is it erroring? Okay, what's that error code mean? 1, 2, 3. 1, 2, 3, 4. Angle sensor error. Speed sensor type. Set the correct sensor type through the user program. Incorrect wiring. Speed sensor is damaged or defective, or the feedback signal is erratic. I'm going to turn that off and check my wiring. Oh, I didn't plug in the Hall effect sensor. Okay, now let's try this. 1, 2, 1, 2, 3, 4, 2, 4. Okay, new one. 2, 4. Throttle error on power up. Oh! I wonder if that's just because this is off right now. Actually, it's supposed to be off, but I see a light on it. How is there a light on it? Is it getting back-fed? Okay, one thing at a time. Okay, where's my camera? Okay, now shut that off because that's driving me crazy. Switch back over to the other one and read. Okay, let's look for differences. Okay, low volt is 40, high volt is 58. TPS low error is 0, TPS high error is 95. And it crashed again. This is the most reliable program ever. TPS type, TPS dead low is 1, 1. Why does it keep crashing? That's really annoying. Okay, TPS dead low is 1. I'm going to write this before it crashes. Controller module does not match Air, what? Does it still think it's talking to the 10K and is confused? KLS 7275. Oh, now it's working. That was weird. Max reverse speed is... Okay, I've got it as 50 on this one. I need to update that. I've already set this to 100. Brake is 0, 15, 0, 0, 0, 0, 15. Oh, brake speed limit is 50 on this one. Brake speed limit is 0 on the other one. What is that? Run regen brake when motor speed is higher than this. Range is... Ah, okay. So I have to do that for regen. Okay, so that's all the same. Cruise is off, anti-theft, anti-slip is off, and change direction is on. Okay, so they are now the same. So now at this point, I should be able to change identification angle to 170. Yep, set it to 170, and this should program it. And right. Wait a minute, turn the controller back on using the key switch. The motor will move. What's that popping noise? I don't like that. I don't think this one did that. All right, well, I'm waiting for a 3-2 beep code. The other one didn't do that. What's it doing? Reset error, fault. That didn't go smoothly. Why did it go into a fault state? One, two, three, 4. 2, 4. That's the same thing I was getting from this one. Okay, so they have different sounding beeps. That's actually useful. That'll help me when I'm up in the cockpit. Okay, you know what? I wonder if it's just because the helm control's off. Okay, I'm going to take a... Right now, I know it doesn't seem like it necessarily, but my nerves are pretty shot. So I'm going to take a second, calm my nerves, and then I will come back and power this up. Why am I telling you this? For you, it's just going to happen. Okay, let's power this up. Okay, so the throttle's in e-stop. The motors are both off, so I'm going to turn off e-stop. Medium speed on 5 kilowatt motor. I'm going to put regen down to 0. That's in neutral. Let's power up the motors. I think I'm on the 10K motor right now, so let's turn on the 10K motor and see if this still throws an error. Controller no power. Oh, because I'm on the wrong motor. Okay. I want to make sure the 10 kilowatt's working first, and then I'll try the 5 kilowatt. And now, do I get some forward motion? Oh, because it's going to the 5 kilowatt motor. Come back. Motor select a 10 kilowatt. Now get some forward. Okay, the 10 kilowatt. The 10 kilowatt's still working. Okay. Now here's the big test. Switch over. Turn on. Do I get an error? 2. Okay, so it's still not happy. Sorry, that's going to be annoying for a bit, but I don't know how to deal with that. Okay, what's it complaining about? 1, 2, 1, 2, 3, 4. So 2, 4 is throttle error on power up. Okay, so let's try resetting it. Why? Oh! That's taking a long time to spin down. That is a very long time to slow down, but let's see if it spins the opposite direction. And it does. Holy crap, that takes a long time to spin down. Okay, it's working. Okay, now let me give it a little... Clearly I've got issues, but that's okay. Let's give it a little bit of forward throttle. Now if I switch motors, this one should spin. That one's coming down. Why is this not coming up? Ah, I have to come to neutral. So if I'm already in motion, because the foot switch is being controlled by the Darlington array. So I bet you the same thing will happen. I'll flip over. No, that one goes right away. Now it's working. Okay, Z stop working? Yes. Why is that one not? Okay, there's something about this one that's not right, but yeah, it's working. I know this is normally where I would probably be like, oh, fuck yeah, whatever. And believe me, I'm feeling it. But it's being tempered almost by a sense of tremendous relief. Okay, it's not perfect. There's some things to sort out, but it's working. It's working. The display is working, the motors are working, the throttle, oh. I haven't tested yet the other throttle. Let me try switching throttles. Okay, so right now, throttle is stopped. Let me switch to my throttle input. Woo! Okay. Okay, so it's got an issue. It's not perfect. But now if I switch motor select. Woo! Okay, so the throttle select is working. I need to figure out why the 5 kilowatt is winding down so slowly. I don't think it's the voltage. Actually, let's just test this right now. If I put this on ground, and I put this on the throttle DAC. That's interesting, that spun up. Okay. I'm reading, why am I reading 1.7 volts? Okay, this is confusing the hell out of this. Why is that one spinning up? There be bugs! E-stop mostly works. Okay. I'm shutting this down. There is bugs to work out, for sure. But it's working. The core is there. We have a minimum viable product. It needs a lot of work. Holy crap, does it need a lot of work. I can control both motors. Now, okay, so what's next? This pile of mess has to be cleaned up. This is absolutely unsustainable. One of the things I'm going to do is figure out how to put all of these switches onto a parallel to serial multiplexer. What that means is, right now, every switch position has to have a dedicated I/O pin into the STM32. And I have 1, 2, 3, 4, 5, 6, 7 switches, of which 3 are bidirectional. So it's like 10 switches. So I've got like 10 I/O pins being used up for switches, give or take. That's a lot of I/O pins I need to free up because I want to be able to have this controller talk to, I don't know whether I'm going to use, I'm going to say CAN bus for now, RS-485. Haven't decided, but I need to free up some pins for that. And the way the multiplexer works is basically you put a whole bunch of switches on a parallel input, you send a signal that says, I want to talk to switch 3, and you read its state. I want to talk to switch 4, and you read its state. And that means that you only have to have enough pins to select the address and read the value. So you can reduce the number of I/O pins off the processor for handling all of these switches. When I do that, I'm also going to sit down and start reworking where all the cables go, and I'm going to try to make a nice clean harness that can go between the STM32 and the breadboard. I'm going to try to do a little bit of debugging. I don't know if I'm going to do a lot of this on camera because, I mean, by this point you've got a pretty good idea of what it's like to be learning all of this, and the channel's about teaching the process of learning, not watch Maddie learn episode after episode after episode. So, yeah, I am running a mile a minute right now in my head. I have a lot to figure out. Anyways, holy shit, I cannot imagine how long this episode's going to be, but if it was less than an hour, I will be shocked. I'm the Digital Mermaid. I will see you next time. If you like this, do the usual doobly-doo thingamajigs, like, subscribe, and if you really enjoy this project stuff, be a Patreon. We have a Discord server. I don't really know what else to offer at this point. I'm open to suggestions. Okay, enough with the self-advertisement. Bye!